Good morning, students. In last class we have discussed about electric field and electric field intensity, its unit and dimensions. Okay, so let's take just analysis of the previous work. As we discussed, the electric field is a space or region surrounding any charged particle such that within this region we can experience the force of the charge, okay, or within this region we can experience the effect of a force of that charge upon another charge. Okay. So, simply it is a space or region surrounding any charged particle such that within this region we can experience its effect or force. Okay. Second thing, when we measure the strength of that electric field, we find the electric field intensity at any point within the electric field is the ratio of force per unit charge placed at that point, and the direction of electric field intensity is measured by the motion of the positive charge. Okay. Another thing that when we measure the variation of the electric field, simply we find electric field is a vector quantity and it is simply represented by E equal to F by Q naught, that means force per unit positive charge. Okay. Force per unit positive charge, that equals to electric field intensity. Okay. And its unit we measure as Newton Coulomb inverse. Okay. So, unit of electric field intensity, that is Newton Coulomb inverse, and when we measure the main physical significance of the electric field, we find the main physical significance of the electric field is that it measures the electric force of any charged particle. Okay. That means we can say in an electric field, if we place any charged particle, then there will be some force experienced on that charged particle. Okay. And the force on any charged particle can be measured by the product of that charge into the electric field intensity. Okay. So, simply F equal to Q naught E. Okay. The force on the charged particle is the product of the charge into the electric field intensity. Okay. So, that is the main physical significance of the electric field, is that it measures the electric force on that charged particle when we place inside an electric field. Okay. So, simply we can say when a charged particle is placed in an electric field, it experiences some force and the magnitude of the force can be measured by F equal to Q naught E. That means the magnitude of the force is equal to the product of the magnitude of the electric field and the charge which is placed inside the electric field. Okay. So, when we place any charge in an electric field, it experiences some force. Okay. So, now let us discuss about different characteristics of electric field intensity. Okay. So, already we have discussed 2 to 3 points. Okay. So, what are the different characteristics of electric field intensity? That means the electric field intensity at any point inside an electric field. Okay. That means we can say when we place any charged particle in an electric field, then the electric field intensity at any point inside an electric field is equal to the force per unit positive charge placed at that point. Okay. As we discussed the definition of the electric field, that is the electric field intensity at any point inside an electric field is equal to the force per unit positive charge placed at that point. That means we can say simply here E equals to F by Q naught. E equals to F by Q naught. Okay. So, that will measure the force per unit charge at that point. Okay. Second thing, the electric field intensity is a vector quantity and its direction is always measured by the motion of the positive charge. Okay. So, the direction of electric field intensity is always measured by the motion of the positive charge. Okay. Third things is that when we measure the electric field intensity, then we find the electric field intensity when we measure mathematically an electric field intensity on any charge particle or the strength of an electric field, what we find, the electric field intensity at any point always varies inversely to the distance of or the distance between the two charges. Okay. That means we can say when we measure the electric field intensity at any point due to a source charge, it always varies inversely to the distance from that source charge. That means when we measure, okay, suppose I take here a source charge, okay, and there is a test charge, okay, and distance between them is suppose r, okay, and when we measure the electric field intensity at the point of test charge due to that source charge, then we find the electric field intensity at the point of test charge varies inversely to the distance from the source charge, okay, and the variation of electric field with the distance, okay, the variation of electric field with the distance from the source charge is clearly shown in the figure. Okay. So, that means we can say as we increase the distance between the source charge and the test charge, the electric field intensity gradually decreases. Okay. So, there is an inverse relation between the distance from the source charge with the electric field intensity. That means when we increase the distance, then the electric field intensity gradually decreases. Okay. And there is a mathematical relation between the electric field and the distance from the source charge, and this mathematical relation can be obtained when we take any magnitude of a source charge that we discuss in later. Okay. So, how the distance and electric field varies, the distance or the electric field intensity varies inversely to the distance between the source charge and the test charge. Okay. So, that is the relation E variation with R. Okay. So, as we increase the distance, the electric field intensity gradually decreases. Okay. And this line meet x axis at infinity. Okay. This line meets x axis at infinity. Okay. So, that relation is obtained when we measure by taking the magnitude of the source charge and the magnitude of a test charge. Okay. The fourth thing about the characteristics is about the unit and dimension. Okay. So, as we find, the electric field intensity is a force per unit positive charge or unit force per unit charge. So, the dimension of the electric field intensity, dimension of E can be given by, as we know, E equal to F by Q. Okay, or simply we can say force by charge. Okay. So, electric field intensity is the variation of force per charge. Force dimension of force is m1 L1 T minus 2, okay, divided by dimension of charge is A1 T1. Okay. So, that is why the dimension of E equals to m1 L1 T minus 3 A minus 1. Okay. So, what we find, the dimension of E equals to m1 L1 T minus 3 A minus 1. Understand? The fourth characteristics is that about the unit, okay, unit of electric field intensity. Okay. So, everyone know electric field intensity is the force per charge. Okay. So, electric field intensity is the force per charge. That is why the unit of force in SI system, that is Newton, and unit of charge is Coulomb. So, that is why we can say the unit of electric field intensity is Newton Coulomb inverse. Okay. So, let us take another way of measuring the charge. Another way of measuring the unit of electric field intensity. Okay. Suppose I may multiply here, suppose the force with multiplication with distance. Okay. Force by distance, and lower part there is a charge. Okay. So, also I multiply here distance. Okay. So, I multiply in upper part distance and lower part is also distance. Okay. So, what we get? Force into distance. Force into distance, that is work or energy. Okay. So, force in distance, that is work. Okay. Divided by charge into distance. So, let as like charge into distance. Okay. So, everyone know what is the unit of work. Unit of work is joule divided by coulomb into meter. Distance unit is meter. So, that is why unit is joule coulomb inverse meter inverse. Okay. So, joule coulomb inverse and meter inverse is also a unit of electric field. Okay. So, let us take the another unit of electric field, that is, suppose I take third way of measuring the electric field, the unit of electric field intensity from this expression. So, that equals to, we find here work by charge. Okay. So, we measure here work divided by charge into distance. Okay. So, unit of electric field work by charge into distance. Suppose I write here work as joule. Okay. Work by charge into 1 by distance. Okay. So, work by charge. Okay. Work per charge or energy per charge is called potential. Okay. So, that is why I can write here, that is potential divided by distance. Okay. So, potential divided by distance, and unit of potential is volt. Okay. Volt by distance. So, that is why we can say voltmeter inverse. Okay. Or we can write here E equals to joule by coulomb into meter. Okay. So, that is equal to joule per coulomb into 1 by meter. So, that is equal to joule per coulomb is volt into meter inverse. Okay. So, electric field intensity has 3 different units. One is Newton Coulomb inverse, or we can say joule Coulomb inverse meter inverse, or we can say volt meter inverse. Okay. So, that means we can say we can measure electric field intensity by 3 different units. Okay. Another things, another characteristics of electric field intensity is that the electric field intensity measures the variation of relative permittivity in between two medium. That means we can say number 6 property or number 6 characteristics of electric field intensity is that the electric field intensity varies inversely to the relative permittivity of the medium. Okay. So, the electric field intensity at any point due to a source charge. So, you can measure here electric field intensity at any point, electric field intensity at any point due to a source charge varies inversely to the relative permittivity between the medium. Okay. The 7th property is that the electric field intensity also measures the potential gradient. Okay, what is potential gradient? Potential gradient means we can say that is the variation of change of potential with a small change in distance. Okay, that the seventh property of electric field intensity is that the electric field intensity always measures the negative potential gradient. Okay, E equal to minus dV by dr. Okay, so you can say electric field intensity is negative potential gradient, dV by dr, that is called potential gradient. What is potential gradient? Potential gradient means the variation of a potential with distance, that is called potential gradient. The variation of potential or the variation of change of potential with a small change in distance, that is called potential gradient. So, electric field intensity is equal to negative potential gradient, E equal to minus dV by dr. Okay. Number 8 property is that the electric field intensity inside a charged conductor. Okay, electric field intensity inside a charged conductor is 0. Okay, so electric field intensity inside a charged conductor is 0. We can prove these two results, E equal to minus dV by dr, that arises in your potential chapter, and this part arises in later in Gauss law. Okay. So, the electric field intensity inside a charged conductor is 0. Why inside the charged conductor is 0? So, there is also we can say when we measure the electric field for a charged conductor, we find for a charged conductor all the charges lies on the surface. Okay. So, that is why inside the conductor there will be no charge, that is why there will be no electric field intensity. Okay. So, we prove this result later. Okay. So, why electric field intensity inside a charged conductor is 0 and how electric field intensity varies inversely as the negative potential gradient. Okay. So, these are the few characteristics of an electric field, that is variation with the distance, variation with the relative permittivity, variation with the potential gradient, and how the electric field varies for a charged conductor. So, for a charged conductor the electric field intensity inside the charged conductor is 0. Okay. So, all the characteristics of the electric field intensity are very important. Okay. So, now let us take the measurement of strength of electric field intensity due to a point charge, due to a in terms of a position vector, due to a group of point charge, and due to continuous distribution of charges. Okay.